Video, we have a dimensional analysis problem. We're told that kinetic energy has this dimension, kilograms times meters squared divided by seconds squared. They also say it can be written in terms of momentum P and mass M. So this is another way to write kinetic energy. First, they want us to determine the proper units for momentum using dimensional analysis. So we're going to set up kind of an equation here. So we have K equals kilograms times meters squared over seconds squared. And I kind of want to reiterate that this M is meters. And then that also kinetic energy can be written in terms of momentum and mass. I want to write this in blue. So it can be P squared divided by 2M. And I want to note that this M is mass, which is kind of confusing. So we are instead going to substitute in for mass kilograms because that's what the unit of mass is. So I'm going to take in an eraser here and I'm going to say kilograms. So now we don't need to worry about this. Okay, so we can find the units of momentum by using this relationship. So we can multiply both sides by this 2 kilograms and say that P squared, which is momentum, is equal to 2 times kilograms squared meters squared divided by seconds squared. So all we have to do is take the square root of momentum, of both sides, and we'll get that momentum equals, well, first we'll write everything out of the square root. 2 kilograms squared meters squared over seconds squared. We don't really care about this 2 because we're only interested in the units, not any constants, so we're actually just going to completely ignore that. So we're going to say that P, momentum, the units are kilograms times meters over second. So that's our answer for part A. Now for part B, they're saying that the unit of force is the Newton, where 1 Newton is kilograms times meters divided by seconds squared. We want to know what the units of momentum are in terms of newtons and something else. So we want to say, what is P in terms of N? Well, N equals kilograms times meters divided by seconds squared. If you look over here, P is kilograms times meters divided by second. So the only difference here is that in terms of momentum, the second in the denominator is not squared. So if we multiplied N by S, we'd get P. So P is equal to N times S. And we'll just confirm this by saying N is equal to kilograms times meters over seconds squared times S means that this will cancel this and we'll get kilograms times meters per second, which is what we initially had. So this is our relationship in terms of newtons and another SI unit. And that's the conclusion to this problem.